Okay, good morning, Year 4. Welcome to your maths lesson for Thursday, the 11th of February. Today we're going to be learning all about fractions greater than 1. So let's share our screen. Not very hopeful, does it? Hold on a moment. Try that again. Share your screen, naughty computer. There we go. Okay, so fractions greater than 1, as I said, and your warm-up for today is a little revisit of area. So can you pause here and work out the area of these shapes? And you'll notice at the top it says, what is the area of these shapes in centimetres squared? So for the purposes of this, we're imagining that each one of these squares, each side of each one of these squares is 1 centimetre long, okay? And if you don't put centimetres squared next to your answer, then your answer is not correct. Okay, pause here and have a try. Okay, so let's display the answers. So it's quite straightforward to work out these. Hopefully you remembered that the area is the space inside a shape rather than the distance around the edge. The distance around the edge is called the perimeter, but we're talking about the area inside the shapes. So I'm hoping that you counted the squares and that gave you your answer. So here, for example, there's 1, 2, 3 squares, so it's 3 centimetres squared. It's not just 3 centimetres. 3 centimetres would just be a straight line that's 3 centimetres long, and that's not what we're doing, is it? We're talking about the area inside. So there's 1 centimetre squared, 2 centimetres squared, 3 centimetres squared, and so on and so forth. Okay, I hope those are all correct. I did them really quickly. So check those, pause here if you need to, and make sure you've got all of those correct. Okay, moving on to today. First, a little quick visit to remind ourselves what we need to do with fractions. So what is a fraction? If I needed to write the fraction of this pizza, let's call it, and we're going to imagine that these are all equal. Now, I know that this one is a little bit bigger than this one, and that's because of Mrs. Eggleshaw's not very good drawing on here. But imagine for the purposes of this that they are all the same size, okay? Because they've got to be equal pieces on the bottom. Okay, so the number on the bottom, the denominator, is determined by how many equal pieces there are. And there are 8 equal pieces, so we're going to put 8 on the bottom here. And then, just as our steps to success says, count how many pieces there are coloured in altogether. And I can see there are 3. So this is the numerator. So that's 3/8, okay? Those are the fractions that we know and love. I really do love fractions. Okay, so what's this as a fraction? Can you pause, please, and have a little try at this one? And we'll come back together in a second. Okay, so I feel a little bit like I've tricked you in this one. Just going to say now, if you put 8 as the denominator, do not worry, okay? Because it was a little bit of a trick, but how many pieces, equal pieces, is each whole one broken into? Well, each one is broken into 4. Okay, so on our steps to success here, how many pieces are there in one whole bar? So in one whole piece, there are 4, okay, and there's 4 in that one too. So each one is broken into 4. Okay, so 4 goes on the bottom. If you put 8, don't worry, I do understand why you did that. It's a really common thing to do. That's why I did a little, oh no! And then how many of them are coloured in? Well, it's 4 there and another 3, so there's 7 coloured in altogether. So 7 is my numerator, and that is going on the top. That's a bit of a funny looking fraction because we've always said the number on the bottom should be the biggest number, because you might be thinking, well, how on earth can you have more than there is coloured in? But obviously how you can have that is there can be more than one whole. So there's 2 wheels here, aren't there? And each one's divided into 4 equal pieces, and 7 in total are coloured in. So that numerator is 7. So this is called an improper fraction. And the reason it's called improper, and it sort of sounds like it's wrong, doesn't it? And it's not, though. An improper fraction is a thing, and it's correct and it's okay. It just means that it's top heavy. So you will hear people call them top heavy as well. And the reason it's called top heavy is because it's got a bigger number at the bottom than the top. And those top heavy fractions, the proper maths name for them is improper fraction, okay? Because that's not really how fractions should go, okay? But that is a correct representation of that picture. So they're called improper fractions when you've got more than one whole, so that you end up with a bigger number on the top. So if we just move on to this then, can you have a go at writing this one as an improper fraction for me? So pause it here and just have a go at writing this, just as we did on the previous page. So think about how many each wheel is broken into and how many are shaded in altogether. So pause and have a try at that. Okay, so once again, each wheel is broken into 4 pieces. So each hole, how many pieces there are in one whole bar? So each hole is broken into 4. So I'm going to put 4 on the bottom for my denominator. And I can see that there are 4 coloured in here and 1 more there. So that's 5 altogether. So 5 goes on the top. So once again, this is an improper fraction, which is how I was asked to write it. It's an improper fraction because it's top heavy. The number on the top, the numerator, is bigger than the denominator. So I've got myself an improper fraction. Have a little pause. If you've got someone with you, you can talk about it. And if not, just have a little think in your head. Pause here and see if you can think of another way that you might write that fraction. And I would use the pictures to help you. Can you think of another way that you might write that fraction? Okay, so the other way that you can write the fraction is like this. So this is called a mixed number fraction. And what you do is you say how many whole ones are coloured in and then do the fractions on the other one. So I can see up here that 1 whole wheel is coloured in. Okay, so that's why I did a big number 1 there. So there's 1 whole wheel. And then on this side, what's left, there are 4 equal pieces. So I put 4 as a denominator again, and 1 of those is coloured in. Okay, so it's like saying there's 1 whole pizza, if you like, and 1/4, 1 little bit. So there's 1 whole one and 1 little bit. So both of these are both correct, and they're both a good way, and they're both the right way of writing and representing this picture as a fraction. So it can be as an improper fraction there, where you just count how many each wheel has, each hole has, and then how many are coloured in. Or it can be how many whole ones are coloured in and then how many leftover bits. Okay, so that's called an improper fraction here. And this one is called a mixed number fraction. You can see why it's called a mixed number fraction, because it's got whole numbers mixed with fraction numbers. So it kind of makes sense, doesn't it? That's called a mixed number fraction. Okay, so with that in mind, true or false, the following diagram represents 2 wholes and 1/3. So pause for a second. Do you think that that is true? The diagram represents 2 wholes and 1/3. So pause, have a think. Okay, what did you think? I can tell you that actually it is false, because if we look at this, there are 2 holes, aren't there? That one is a whole one coloured in, the whole shape is coloured in. And that one, the whole shape is coloured in. And they're definitely thirds we're talking about, because each one's divided into 3. But you can see on this last bit, so it is 2 holes, but it says 1/3, and actually 2 of those thirds are coloured in, aren't they? So actually it shows 2 holes and 2/3. So well done if you spotted that. And don't worry if you didn't. This is all a bit new still at the moment, isn't it? Okay, so we need to place the following fractions in their correct place on the number line. Now, I know that you can't draw this easily in your book, so it doesn't have to be set out perfectly. If you've got a ruler, that would be really helpful to just draw a number line, put the numbers that you can see on, and then just put these roughly where they would go on your number line. And I'll show you in a second where they go exactly. And you can see if you're kind of in the right place, okay? So pause here and have a try at that. Okay, now you can see quite clearly on here, without me moving my answer splodge, as I like to call it, between 0 and 1, it is broken up into 7 equal sections. Can you see? 1, 2, 3, 4, 5, 6, 7 takes us up to the number 1. So we've got 7 equal pieces here. And so I know that's why I've got 7 on the bottom for my denominator, okay? Because each whole one is broken up into 7. So there's 7 equal pieces there, and there's 7 equal pieces there, okay? So I've got sort of 2 whole ones. So here, this one, oh, it won't, right, hang on, that's why I've written them down there. So I put my first one, let me make this smaller slowly, grand reveal. There we go. So 2/7 goes there. There's 1/7 here and 2/7 goes here because it's 2 of the 7 pieces. Okay. The next one along, let's have a little look, another reveal. There we go. We get to 5/7. Okay. So we've got 1/7, 2/7, 3/7, 4/7, 5/7. Okay. So you can take this one away now, get this one out of the way. Now, I've just shown you a little bit where those go. Okay, now the rest of them are slightly more tricky. If we're looking where to put 9/7, okay, once we get to 1, we're up to 7/7. So let's go again. We've got 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, 7/7, which is all of them when you think about it. If you ate 7 pieces of 7 pieces of cake, there were 7 pieces of cake and you ate 7 of them, that's the whole one, isn't it? And then we're still counting in 7ths, so we can't change the denominator because this one's chopped into 7 equal pieces too. So we're on 7/7, and we're just going to keep going. 8/7, 9/7. So we get ourselves up to 9/7 there, okay? And then we just keep going for our 12/7. So 9/7, 10/7, 11/7, 12/7. Okay, so you've got 12/7 down in there. All right, so if we looked at that fraction there, 9/7, we would know that that's a whole one and then 2 extra little bits of 7, okay? Makes it up to 9/7. Let's move on. Okay, Jack and Leah are discussing this image. And Leah says, it is 3 wholes and 2/3. And Jack says, it is 11/3. Who is correct? Convince me. So have a little look. What do you think? Which one child do you think is correct? And tell me why. Okay, and the little hint before you pause, make sure you check out both of their answers, okay, before you decide. Pause here and have a go. Okay, so the answer is Jack and Leah are both correct. Trick question for a Thursday morning, because 11/3 is equivalent to 3 wholes and 2/3. So I'm just going to explain that to you in a little bit more detail so that you can understand. So I think Leah's, I think you can see quite easily, and I think lots of you might have thought that Leah was correct because she said it's 3 wholes, and it is, isn't it? That there's 1 whole, 2 wholes, 3 whole ones, and 2 of the 3 coloured in there, so 2/3 there. So that's definitely right. So well done, Leah, you're right. Okay, when Jack does his, he's saying it's thirds, and there are thirds, because it's always in thirds, look, because each of the whole ones is divided into 3, so it is thirds. And let's count how many thirds there are that are coloured in all together. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we write that out as a fraction here, there we go, 11/3. That's what that one would look like. And Leah's one, she's saying, right, it's 3 whole ones. This is where I have to make my 3 a bit bigger to make it clearer. She's saying there's 3 whole ones coloured in, which there is. And then there are 2/3, so 2/3, like that. So hers looks like that. There we go. So what Leah has done is she's written it as a mixed number fraction. Do you remember we said a mixed number because there is whole numbers, there's a whole number there and a fraction. So she's done it as a mixed fraction, and Jack has done it as an improper fraction, or sometimes we call it a top-heavy fraction because that number is bigger on the top than it is on the bottom. Okay, so the answer is they're both correct. That was a bit mean, wasn't it, to give you one where they were both correct. Okay, your challenge for today. The first one, silver, you have to work out if it's true or false. The following diagram represents one whole and one half. So you have to decide if that diagram is if that's correct or not. Okay, if it's true or false. And then the bottom one the same. The following diagram represents 2 wholes and 1/3. So tell me if it's true or false and prove it. If you think it's true, great, tell me why. And if you think it's false, maybe show me with a diagram what it should look like. And then this is just an extra little silver challenge today. Write an improper and mixed fraction for each diagram. So if you look back here, when I did, this is my mixed number here that I did for that one, and this is my improper fraction. I just want you to have a little go at these two and see if you can do an improper fraction and a mixed number fraction for each one. Okay, so for a mixed number fraction, you'll say how many whole ones are coloured in, and then do the fraction of the other one. And then for the improper one, you just what number's going on the bottom. So for this one, the denominator is 4, isn't it? Because it's divided into 4s. And for this one, the denominator is 3. And then how many are shaded in. Okay, so that's that. And what I will do in a moment is just pop that steps to success on there as well, because that's quite helpful as well. Okay, so pause here and have a go at silver, and I think everyone needs to have a go at silver before they move on today, please. Okay, right then, let's have a little look at this quickly. So, true or false, the following diagram represents 1 whole and 1 half. Well, this one is false, okay, because it represents 1 whole there that I can see. Excuse my writing, and then 1/4, because there are 4 equal pieces in that diagram and one of them is coloured in. If I wanted it to represent 1 1/2, that's half of that shape is not coloured in, is it? Only one of those pieces. There are 4 pieces, so if I wanted half of it to be coloured in, then I'd have to colour in that slice as well. Okay, I'd have to colour in 2 out of the 4. Okay, if I wanted it to be like that. Now, to write this as an improper fraction, what I need to do, try with the pen as well, it's a bit quicker. I know there's still going to be a 4 on the bottom because it's divided into 4. Each whole one is divided into 4 equal pieces. So count how many pieces there are in 1 whole bar. This is the denominator. So in 1 whole bar, there are 4 pieces. So put 4 on the top, at the bottom, sorry, and then count how many pieces coloured in all together. So 1, 2, 3, 4, 5 pieces are coloured in altogether. So, whoop, and put 5 on top. So that is it as a mixed number, and that is the fraction as an improper fraction. Down the bottom, oh, and it was false, wasn't it, that one? So we'll do a little cross by that one because it was a false one. This one, true or false, the following diagram represents 2 wholes and 1/3. So the answer is it is correct. It's true, because there are 2 whole ones. So if I'm doing I was writing them, wasn't I? I'm doing my whole ones. There are 2 whole ones, and counting in thirds, my denominator is a 3, because each whole is divided into 3, and so there's 2 whole ones there. I've done those, and how many of that last whole one are coloured in? Just 1. So it's 2 whole ones and 1/3, which is what she has said. And then if I want to write that as an improper fraction, top heavy fraction, again 3 is going on the bottom because each whole is divided into 3. And how many are coloured in? 1, 2, 3, 4, 5, 6, 7 coloured in. Okay, so that is it as an improper fraction. Okay, right then, moving on to the gold activity for today. There's a couple of things there for you to do. So Emily and Jacob are discussing this image, and they both say different things, and you have to say who's correct and convince me, and the same for the next one. So I'm not going to go through the answers to this. If you have any problems with it, then you can drop me a dojo message or something, and we can talk through it. But it will take too long. I think you've already been on for a really long time. Let's have a go at this. Pause here. And then finally, there's a platinum activity there, which I won't read through now. You can read that for yourself and have a try. And I'd love to see the work that you've been doing on your portfolios. I'll look forward to seeing it. Okay, that's the end of our lesson for today. So I'll share my screen and I will see you tomorrow. And it's Friday again tomorrow. And also, importantly, it's the end of term. So it's half term after tomorrow. Okay, I will see you tomorrow. Bye-bye.